Welcome to this web lecture in which we explain the importance of always showing the visible system status. Here we see a typical example of an application that shows the status of a system. It's the dashboard of a car. You see many gauges, right, that show what is going on in terms of speed and the revolutions per minute of the engine. You can see how much gas there is still in the tank, but we see a lot more. Right? Now, it should always show what we care about in the car. It should show the status of the car using the functions that we think the car has. We don't care about all the technical functions the car really has. Now, if we look closely at such a dashboard, we will see that there are many lights that are on for a brief moment when we start the car so that we can notice which lights are there. But they show us status of the battery, whether there is enough oil in the car, whether the ABS system is working. Lots of things that, yes, of course, they should all be working, right? But it doesn't really help us to say, for instance, okay, there is an alarm, you should stop because the oil level is insufficient. If we have to stop, we will call a mechanic, right, who deals with the technical aspects. We don't deal with them. We just want to see on the dashboard the things that, as a driver, we care about while driving. We have a screencast that will show you in computer terms what it means for the system to show or not show the status. In this screencast, I'm going to try 3 different Unix commands. And although the system's reaction to these commands is very different, it doesn't show that at all. Let us first start with the cat command. I have entered the command to, in fact, copy everything that I would type to dev null, which means it's going nowhere. So the system is actually waiting for me to do something, to type input. But it isn't prompting me to do that at all. It appears like the system is doing nothing. Now we try the tar command. Again, it appears like the system is doing nothing. Is it waiting for input? Is it really doing nothing? We can actually check the system status and find out that the system, in response to this command, is now suddenly reading a lot of data from the disk. What the tar command is doing is it is copying my entire home directory to an archive. The archive is then sent to dev null, so it's not going anywhere. So the system is very busy, but the reaction of the system is just the same as with the previous command. I will interrupt this. And I will ask the system to now do something else. Again, it looks like the system is maybe doing nothing, maybe waiting for input, maybe very busy doing something. But in fact, what this command does is the system is really doing nothing for 30 seconds and then it will wake up again. So what this screencast shows is that whether the system is idle, in sleep, very busy with tar, or waiting for input with cat, there is no way that you can tell from what the system displays that it is in these 3 different states. The visibility of the system status, or more generally, the observability, because it can also be by audio, just means that you keep the users informed about what is going on. The screencast showed that we need to know whether the system is busy or idle or waiting for input. But when a system, for instance, is busy, we also want to see a progress bar that indicates how much longer we have to wait. We also need to give fast feedback about system status to avoid repetition. When we're in the elevator and we press the button, we need to get very fast feedback by a light coming on. Otherwise, if we don't see, right, oh yes, the command to go to floor number 5 has been registered, we will repeat that action. And in the elevator, that doesn't really matter. But if we do the same with the computer, we start an application, there's no reaction, we will just start it again and make the system even more busy than it already is. Your status is now that you are ready to go on to the next web lectures on design principles. Thank you for participating.